Today we're going to deconstruct the Serpentine Pavilion from BIG from 2016. And to not waste any time, because it's going to be a pretty long course, I've already set up some line work in Rhino that will represent our shapes. So we don't have to be bothered by that. It's a close approximation of the actual shape. It's not the exact shape, but that doesn't really matter. It's about the process that matters. So let's get started. And we're going to work mainly in Grasshopper during this course. So let's fire up Grasshopper. The first thing we're going to do is to link in our curves. So let's insert a curve component. And I'm going to insert two. So we have one for the left side of the wall and the right side of the wall. And let's link in our curves. So that's the left side. And for the right side. Great, so let's also label them so we don't mix them up. So this was the left side. And this is the right side. The reason why I distinguish between left and right is that all the operations we're going to perform them on one side of the wall. Because when we're done, like all the way in the end of the course, we can simply copy everything we did for the right side and apply it to the left side with some minor adjustments. So the next thing we're going to do is to loft those lines together so we get the actual surface using the loft component. So the settings for the loft component are fine. And to continue, the next thing we're going to do is to insert our rectangular grid. And we're going to use a simple rectangular grid for that with a base point. So let's first insert our base point. Let's name it also base point. And let's set a point in Rhino, because we're going to project our grid on top of this surface, as we will see in a second. Let's pick it more or less in the beginning of our surface, more or less here. And let's also insert our rectangular grid, which is this one. Now its default is set to the XY plane, but we want it to be the YZ plane. And there's a component called YZ plane, which is this one. So if you connect it now, you see that the grid is flipped to the YZ plane, which is nice. The only thing we need to do is to connect our base point to it so it starts where we want it to in the beginning of our pavilion. Great. So we can turn off this component. So let's also change the settings a little bit because it's set to a distance of 1 and 2 meters. So the SX is 1 and the SY is 2 meters. So let's insert a number slider. And let's set the SX to 0.5, so half a meter. And the SY to 0.4, which is going to be the height of our brick. And for the amount of bricks in the X and Y direction, let's use 50 for the EX. And let's use 32 for the EY. So these numbers I kind of made up a little bit. I know that the brick is 0.4 in height, but I'm not quite sure about the other width, let's say. So I think 0.5 more or less covers it. If you want to change these numbers, that's totally fine. So let's continue. The next thing we're going to do is to get the center point of these bricks. And we're going to use that center point to project them on our surface. We're going to do that by using a component called discontinuity. This will get all the corner points of our initial rectangles. If I zoom in a little bit, you can see that. And from all the 4 corner points, we're going to get the average, which will result in the center point. Nice. We could use any point, by the way, to project on our surface, but getting the average will result that if a point is too close to the edge of the surface, it might or might not get projected on top of it. So this is kind of a security that all the points will get projected properly on the surface. So the next component will be the project point. So let's insert our points. And the direction is the positive x direction, which I sneakily already knew. That's why I positioned our rectangular grid behind our pavilion, so we can just insert a unit x vector. And our geometry, this will be our initial surface. So let's connect it. Nice. So now you can see that all our points got nicely projected on top of our surface. And the last thing we're going to do is to move our rectangles to these reference points. So we first need to create a vector for that. So let's create vector 2 points, which creates a vector between 2 points. And those 2 points will be our initial average point, which goes in the A, and our projected point goes in the B. And let's move our rectangles using the move component, which are our initial rectangles. And the only thing we shouldn't forget is to graft the G, the input, because the data structure is one more. So now if I connect the V to the translate, it should, yes. So now you can see all our rectangles got nicely orientated on top of our surface. So that's nice. So we can do the same thing for our left side as well. And let's copy the components we need for the left side, which is only going to be these ones. So simply hit Ctrl+C, Ctrl+V, move them up a little bit, and let's deconnect them. So we need to deconnect our geometry. And the input points are the same from our initial rectangular grid. Just the geometry to project it to is different, which is going to be the left side. And that's it. So now we have also the left side with our rectangles orientated proper. So that's nice. Let me order our components a little bit better. So this one goes here. So we kind of have a separation in our definition. So everything we do on the bottom side is for the right side, and everything we do on the top side is going to be for our left side. So we're basically gonna have a division along this line here that will separate the left and the right side. In the next lesson, I'm going to show you how to quickly visualize our bricks by extruding them according to the surface curvature. And I'm also going to show you that it's quite easy to achieve this. But this is not going to be the ultimate goal of this course. I want to show you that Grasshopper is also really powerful into thinking about how to build a project like this by thinking about constructability and how to standardize all the bricks into a certain set of lengths. And also thinking about how to documentate these bricks with a certain set of tags and rules. because I think that's really interesting also to see the things you can do with Grasshopper besides just for visualization purposes, let's say. Thank you for watching, and I'll see you in the next lesson.